Let's do some trigonometric equations. First equation is 2 sine of x plus 1 equal to 0 on the interval 0 to 2 pi. Sometimes the questions will say solve this for x between 0 to 2 pi. Now the solution begins like a regular equation. Try to detach from this x as much as possible. So 1 should go to the other side as -1, and you divide by 2, so you get sine x equal to -1/2. But then, to figure out when sine is equal to -1/2, you will need the graph of the sine function in this interval. So let's draw that. And along the way, we should use the fact that 1/2 is what I like to call as the small value. If you don't know what I'm talking about, you should probably go back and watch the video that's titled Remembering the Values of Sines and Cosines is Easy as 1 to 3. There's that video of mine, and then you'll know what I'm talking about. This is 1/2, which is the small value of the three kind of values that you see when you consider the sine and cosine values as special functions. It's easy as 1 to 3. Because this is the small value. This is medium, large. Okay. Since the interval is given as 2 pi, take half of it to get pi. Half of pi is equal to pi/2. And the midpoint between pi and 2 pi is, you add these two numbers, which gives you 3 pi, and you divide by 2 because average is really the midpoint. And then let's draw the sine curve. It goes like 0 up, 0 down, 0. Okay. Now we have to locate this -1/2 from this graph. First, we have to use the fact that it's negative. Negatives only appear in this side of the sine curve. And in here, remember there are three kinds of values: small, medium, large. And here it could be like large, medium, small. Among these values, the one that we're looking for are the negative small values. So this one and that one. Okay, that's all we need to figure out now. Okay. I still like to think in degrees. So let's start with degrees. See, these are 30, 45, 60 from this angle here. So pi is 180 degrees. And since this is the nearest, that must be the 30-degree one. So you add these two numbers. That's 210 degrees, which is 7 times 30 degrees. And the reason I do this is because I actually remember what 30 degrees is in radians. 30 is 180 divided by 6, right? If you take pi, which is 180 divided by 6, you get 30 degrees. 30 times 7 gives you 210 degrees. So we know that this point, the first number that you run into is 7 pi/6. Okay, what about this one? This one is, here's 360, and you can also go back by 30, 45, 60. So it's 360 degrees minus 30 degrees, which gives you 330 degrees, which is 11 times 30 degrees. Again, that's 11 pi/6. So this is 11 pi/6. And that's it. You have the value of x, which is, the answer is 7 pi/6 and 11 pi/6. Okay, here's another example. What if you have a different domain rather than 0 to 2 pi? So suppose you're given, the second example I want to do is, suppose you're given, say, square root of 2 cosine x minus 1 is equal to 0, and we have to solve for x between pi and -pi. How do you do that? Oh, solution. Right, equal 2 cosine x minus 1 equal to 0. You move the 1 to the other side. You move the 1 to the other side to become +1. divide by square root of 2, and then you need to rationalize the denominator, so you get square root of 2 and over 2. Okay, this is the value I like to call the medium value, and again we should be using the graph of the cosine. Now it would be ideal if you remember the graph of cosine from negative pi to pi, but I only remember the one from 0 to 2 pi. So let's first draw that. These are the same, but then for the cosine it goes like up 0, down 0, and up. Okay. Now remember that cosine or sine or tangent, all trig functions are periodic functions. So if you know the graph for one full period, you can copy and paste Control C, Control V to the left side and to the right side, and it extends to infinity. But let's say we took this and copied over to the left side. It's like this. Now, because of symmetry, if this is pi over 2, this must be negative pi over 2. If this is pi, that must be negative pi. Okay, so since we only need the graph from negative pi to pi, let's draw the graph again. Pi, negative pi, and here's 1. Goes like that and that. Okay, that should be more symmetric. It's not, so let me do this again. Let's try. Okay, so let me mark the pi over 2. This is pi over 2. That's negative pi over 2. And let's go like that. The same thing for here. Okay, now that's much better. Okay, now what are we looking for? We're looking for the medium size value, radical 2 over 2. And remember, in each of these quadrants from 0 to 90 degrees, you have 3 special angles, 30, 45, 60, and also 30, 45, 60 from the previous angle. Right? Okay, and among these, the medium-sized ones are these. Okay, and if you look at it, these are negative sides, so we don't care. We're looking for positive medium size. So the only medium size you see is right here with the green lines. Okay, so you have the green lines. We have to figure out the angles here. What are the angles? We know this is 45 degrees, which is 180 divided by 4. Same thing over here. This is actually by symmetry, this is negative pi over 4. Okay, you can use some symmetry to figure out the angles. So in this case, the answer is negative pi over 4 and also pi over 4. Okay, I guess the harder question is when you have a quadratic equation in terms of trigonometric functions. That will be harder. Let's try that as the next example. Suppose you're given, example 3, suppose you're given 2 times sine squared of x plus sine of x minus 1 equal to 0, and you have to solve for x between 0 to 2 pi. Okay, let's try to find the solution of this. Okay, you have to remember what sine squared of x means. It means sine of x squared. Now, this may surprise you, but this can be factored. It's hard to see how it can be factored in this format, so a nice way to see how it can be factored is to do a change of variables, and using the change of variables we can figure out the factoring. So let's just call sine x as t, because then this becomes 2t squared, sine x is t squared, plus t minus 1. And then you do something called factoring by grouping, if you know that. or you can just do trial and error. See, 2t squared, so one must be 2t and the other should be t. And you have negative 1, so it must be plus 1 minus 1 or minus 1 plus 1. Okay, so let's try this. Minus 1 plus 1. Let's see if it works. Okay, negative, so if you FOIL this, 2t times t will give you 2t squared. 2t times plus 1 gives you 2t, but 2t times negative 1 times t gives you minus t. So in the FOIL, first, outer, inner, last, the outer one and the inner one gives you each 2t and negative t, which adds up to t here. And the last one gives you negative 1. So negative 1 times 1 gives you negative 1. 2t times t gave you 2t squared. Okay, so I got lucky and got it right in the first try. The only option could have been 2t plus 1 and t minus 1. But if you do that, you will get 2t squared minus t minus 1 instead. So you would know that it's wrong. Okay. So by trial and error, you can do this, or you can also do something called factoring by grouping. The beginning of pre-calculus explains how to do factor by grouping, how to do quadratic polynomials factoring. If all these fail, another thing you can do is you can just use the quadratic formula, which is negative b plus minus square root of b squared minus 4ac over 2, and that could also yield the same answer as what I'm doing now. Okay, but since we have it factored, let's just use this. Okay, so when is this true? That's when 2t minus 1 is 0, or t plus 1 is equal to 0. If you have two things multiplied to give you 0, each individual things could be 0. Okay, so 2t, at least one of them have to be 0. So either 2t minus 1 is equal to 0, in which case t becomes 1/2, or t is equal to negative 1. Okay, did we solve the question? Well, not so fast. The pitfalls of doing change of variables is it's often very easy to forget that t is not what we were looking for. We were looking for x, and t is not x, and t is really sine x. So we're looking for sine x equal to 1/2, because t is sine x, and also when sine x is equal to negative 1. That means we have to draw the sine curve again. Let's draw the sine curve. 2 pi, pi, pi over 2, 3 pi over 2, and then you do 0 up, 0 down, 0, and we're looking for the small values, which is closer among the three small, medium, large. It's closer to the 0, and this one is closer to the 360 degrees. So this is like pi over 6. It's the 30-degree one. And this is 180 minus 30 degrees, which is 150 degrees. And that one, in terms of radians, is 5 pi over 6. Okay, so those are the two places where the sine becomes 1/2. How about where does sine x become negative 1? That's this place only. The minimum value of the sine function is negative 1, and it appears at 3 pi over 2. Therefore, the answer is x could be pi over 6, 5 pi over 6, or 3 pi over 2. And these are the solutions of the sine x squared, this equation over the interval 0 to 2 pi.